This lesson is 1.5 writing numbers as a product of prime factors. Today we're going to learn about the difference between prime and composite numbers, and we're also going to be finding prime factorizations using a method called the factor tree. In this section we can think about key ideas for prime and composite. Prime numbers have only two factors, itself and the number 1. Composite numbers have more than two factors. And it's good to note that the numbers 0 and 1 are neither prime or composite. Another thing that's good to remember is this sneaky little guy right here, the number 2. Number 2 is your smallest prime number. So even though it's an even number, it is a prime number. So it has no factors other than 1 times 2. And then we can look at other prime numbers like the number 3, 1 times 3, 5, 7, 11. Certainly you will notice that a lot of prime numbers are odd numbers, except for the number 2. Composite numbers, though, don't be tricked that they're all even numbers, because look at a number like 9, right? 3 times 3 is 9. So there's lots of odd numbers that are composite numbers as well. So, for composite numbers, some are odd, some are even. 24 is a very common composite number. Lots of factors, right? 1 times 24, 2 times 12, 3 times 8, 4 times 6. So lots of factors are making this composite number 24. Prime numbers, only two factors, 1 and me, right? So if you look at the word prime, it's kind of cool. 1 and me, 1 and myself, then it's prime. 2 is the first prime number, and remember 1 and 0, neither prime nor composite. Now for prime factorization, we're going to do something really cool, I think. It's called the factor tree method, and we're going to find all the factors of 24, and then we're going to circle the prime factors. So we know that 24 is a composite number, but we want to be able to factor tree it. Now I'm going to show the first method, which is my preference method, which is where I'm going to use the littlest prime numbers, 2, 3, and 5, and then I'll show an alternative method. Okay. First method is the way that I do it. What I'm going to do is always go with my smallest prime number, which is 2, and see if the number that they've provided me with is divisible by that. 24 is divisible by 2. 2 multiplied by 12 makes 24. So I'm going to circle that 2 because I'm done with that one. Now I've broken the 24 down to a 12. I'm going to repeat asking myself, is this number divisible by 2? And it is again. 2 times 6 makes 12. And I keep going. Is 6 divisible by 2? It is. 2 times 3 is 6. And 3 is also a prime number. So I'm done now. So as the factorization, what I do now is the ones that I've circled are all my prime numbers. I can write the prime factorization of 24 like this, 2 times 2 times 2 times 3, or I can write it as 2 cubed, because I have 3 of those little 2's, times 3. So we have that option. These equal 24, and if I want to use exponent, 2 cubed times 3 is also equal to 24. Alternative method I don't like as much. The book shows it, and I'm going to show it here, which is where you would grab any two numbers that you think of that make 24, any two. They happen in the book to say, well, okay, the first that comes to mind is 4 times 6. This is totally fine method, but I just find It's a little bit hard to be as systematic as the way I showed the first one. What you do now is break down these numbers based on the prime factors. So you do have to go back to, okay, how do I break this down into my littlest numbers? Well, 4 is 2 times 2. Those are both prime numbers. And 6 is 2 times 3. And these are both prime numbers. So I end up with the same answer. So it's not that that method is bad, it's just that for a small number like 24, it works just fine, but for larger numbers, it can get a bit tricky. But you have a choice, and whatever works best for you is what you should do. So we're going to do a couple questions here together on the Do Together page 32. So question number 1, which of the following are prime? Circle the prime numbers in the list below. So we want to make sure only itself and 1 can be factors of the numbers. 14, we know 2 times 7 makes 14, so that's out. 13, nothing makes 13 except itself. 29, you always have to be really sure. Just because it's odd doesn't mean it's prime. This one doesn't have any factors other than 1 and 29. Remember our little sneaky guy? The number 2 is our smallest prime number. 6 has 2 times 3. 11 has nothing, 1 times 11. 30 has lots of factors. We saw that in our last lesson, 2 times 15, right? 3 times 10, and so on. 31, nothing makes 31 except for 1 times 31. Same goes with 17, nothing makes 17. But 21 has more than 1 times 21. We have 3 times 7 there, so that's a composite number. For number 2, we're using division method or factor tree. So we're going to use factor tree method here. Division method is that second method that I showed in the example above. I'm going to go with the factor tree method. I'm going to be looking at my littlest prime numbers and trying to divide by those. So for 48, I'm going to divide that by 2. That makes 24. I'm going to continue to divide by 2 as long as I can. 24 divided by 2 makes 12. 12 divided by 2 makes 6. 6 divided by 2 makes 3. I find dividing by 2 goes really quickly, and 3 is also prime, so I'm ready to go here. And I'm going to write this with exponents. 1, 2, 3, 4 of those 2's times 3 is equal to 48. 2 to the power of 4 times 3 is 48. Now for 75, we cannot divide by 2. So what we want to do if we're using factor tree is go to our next prime number, which is a 3, and try that. 75 does divide by 3, makes 25. Again, can't divide by 2, can't divide by 3, but I can divide by my next smallest prime number, which is a 5. So I'm going to do that. 5 divided by 5. Sorry, 25 divided by 5 is 5. So that's it. I have 3 as my prime number, 5, and I'm left with 5. So 75 is the result of 3 times 5 times 5, or you can write 3 times 5 squared is equal to 75. So now you can try out the exercises for lesson 1.5.